Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss one of the GATE question which came in the year 2008 related to TLB. These kind of questions will help you to understand the concept in a better way. So I request everyone to watch the complete video for better understanding. First let me read out the question, then I will discuss the solution with you. Look at the question. A paging scheme uses a TLB. TLB is Translation Look-Aside Buffer. A TLB access takes 10 nanoseconds and main memory access takes 50 nanoseconds. What is the effective access time in nanoseconds if TLB hit ratio is 90% and there is no page fault? They have given 4 options. We need to solve the question and find out what is the right answer. Before solving this question, let me discuss what is the purpose of TLB and how to compute the effective access time. Then I will solve this question. Now, we know that a process is divided into phases. Okay, this is a process P1 is divided into phases such as P0, P1, P2, P3, P4, P5 pages are there. Okay, so totally 6 pages are there. And we know that main memory is logically divided into frames, and some part of the main memory is occupied by the operating system, and then the remaining frames we will have. Okay, now the frame size will be equal to page size. So meaning is that one of the page of a process can easily fit in one of the frame in main memory. Let's consider that we have frame number 0, frame number 1, frame number 2, frame number 3, frame number 4, frame number 5, 6, 7, 8 frames are there. Now let's consider that in frame number 1, page number 1 is available. In frame number 3, page number 5 is available. And we know that each process maintains its own page table. Okay, each process maintains its page table, and the number of entries in the page table will be equal to number of pages in a process. Now how many pages are there? 6 pages are there. So we will have 6 entries: page 0, page 1, page 2, page 3, page 4, page 5. Now what the purpose of page table is? Page number 0, is it available in the main memory? No. So present or absent bit will be having value 0, meaning is that page number 0 is not available in the main memory. Page number 1, yes, it is available in the frame number 1. So present or absent bit will be 1, meaning is that page number 1 is available in the frame number 1. So it is available in the main memory. And page number 5 is available in the frame number 3, so it is present, and remaining pages are absent, meaning is that they are not in the main memory. Now we know that even the page table should be stored in one of the frame in main memory. Suppose let's take that page table is stored in the frame number 7. Okay, now CPU generates the logical address. Okay, now the logical address consists of page number and page offset. Okay, now whenever CPU generates the logical address of a process P1, first it will access the register. Okay, it will access one register. It consists of base address of this page table, meaning is that in which address the page table is there, because if it wants to access a particular page, it will be available in the main memory. So that information in which frame that particular page is available will be there in the page table. So first you need to get the page table, then you need to look at whether the particular page is available in the main memory or not. If it is available, in which frame it is available, we will get the information from the page table only. So first we will have to access the base address of the page table. Okay, for that base address we will add the page number, and then we will look at, suppose let's take that this is page number 1. So you will go to the page number 1. Okay, and then it is there in the frame number 1. So in frame number 1 you will get the access. Is it clear? Now how many access you are doing? First is that you need to access the main memory once to get the page table. Am I right? One is that we are getting the page table. then we are getting the particular page. So 2 times we are accessing the main memory. Is it clear? Are you able to understand? If main memory access time is 50 nanoseconds, 2 into 50 nanoseconds will be 100 nanoseconds to access one instruction in a particular page. Is it clear? Are you able to understand? So main memory access time will be more. So they thought that why can't we use some other what you called a memory where we can store the page table which will take less time as compared to the main memory. So they have introduced a concept called TLB, which we'll call it as translation look aside buffer. Even it is called as cache memory or associative memory. Okay, so we have a TLB. Okay, so TLB is nothing but your cache memory. Okay, now the cache memory size will be less as compared to the main memory. Okay, so if your size is less, then your access time will be less. Is it clear? Are you able to understand it or not? And then if the size is less, we can store less information only. So what we will do is that instead of saving the entire page table, if we save the entire page table, then memory will be wasted. So what usually we'll do is that TLB consists of few pages information. Like let's take that page number 1 is available in the frame number 1. Page number 2 is not available, so that information will not be there. Phrase number 5 is available in frame number 3. So this information will be there. So first, whenever the CPU generates the logical address, instead of looking at the page table, first it will search in the TLB. If that information is available, let's take that page number 5 CPU want to access. Now page number 5 information is available. Yes, it is there in the frame number 3. So it will go and get that information. Suppose let's take that page number 4 is available in the frame number 6. Let's consider that that information is not available in the TLB. So first CPU will go and search in the TLB. In TLB we will have the tags. By looking at the tags, it will identify whether the particular information is available or not. Okay, more related to the cache memory I have discussed in the computer organization playlist. If you want to look at it, please go through that cache memory concept, then you will understand in a better way. So here what I want to say is that first, whenever the logical address is generated, CPU will search it in the TLB. If that particular page information is available, we will call it as TLB hit. If it is not available, let's take that CPU want to access the page number 4. Now page number 4 information is not available in the TLB, so it is a miss. Okay, so we will call it as a TLB miss. If TLB miss is happen, then it will search in the page table. Okay, if it is not available in the TLB, then it will search in the page table. So where the page table is there? It is there in the main memory. So it will go to the main memory and access the page table, page number 4. Yes, page number 4 is available in the frame number 6. Okay, are you able to understand it or not? So if particular information is available in the TLB, we will call it as a TLB hit. Okay, and then we will go to the main memory and access the information. If that particular information is not available in the TLB, we'll call it as a TLB miss. Then we will access the page table from the main memory. Then we will access the particular frame from the main memory. So what I want to say is that effective access time, okay, will be depend on the TLB hit ratio. Is it clear? So effective access time, let me write it as EAT. Effective access time, if P is the probability of hit ratio, means P is the hit ratio. If it is a hit, okay, if a hit means information is available in the TLB. So access time for the TLB plus main memory access. Are you able to understand it or not? Because whatever the page number CPU searching, if it is available, that information is available in the TLB. Meaning is that in which frame that information is there. Okay, suppose let's take the page number 5. Page number 5 is available in the frame number 3. So it will access the page table, then it will go to the main memory. Are you able to, and here it is accessing the TLB, then it is accessing the main memory. So if it is a hit, TLB access time plus main memory access time. If it is a miss, means is nothing but 1 or minus P. Okay, is it clear? If it is a miss, first we are searching in the TLB. Am I right? If we search in the TLB, then only we will understand that that information is not available. Then we need to access the page table. Now page table will be there in where? Main memory only. So one main memory access for the accessing the page table, and another memory access is to access the particular information. Is it clear? Are you able to understand? So using this formula, we can solve this question. What they said, a paging scheme uses the TLB. Okay, TLB access time is 10 nanoseconds. Okay, this information they have given as 10 nanoseconds, and main memory access time is 50 nanoseconds. Okay, and what is the effective access time? They are asking this one, and TLB hit ratio is 90%. So 90 by 100, meaning is the 90% means, suppose let's say that you are referring 100 times, then 90 times that information is available in the TLB. Okay, and if 90 times the information is available, 10 times the information is not available. So 10 by 100. Is it clear? Are you able to understand? Then TLB access time, okay, plus main memory access time plus main memory access time. Okay, using this formula we can solve it. 90 by 100 into 60 plus 10 by 100 into 110. Is it clear or not? Now we can cancel it, and this one we can cancel it. So we got 9 6 54. Okay, this one you can cancel it, this one and this one you can cancel it. So we got 11. So 54 plus 11 we got, which is nothing but 65 nanoseconds. So the right answer for this question is option C. I hope you have understood. Now you can ask me, sir, what is the purpose of page fault? What is the page fault? Whatever the page you are looking at, if that information is not available in the main memory also, then it is a page fault. Is it clear? Suppose let's take that CPU is searching for the page number 3. Whether the page number 3 is available in the main memory, it is not available. Then they will say that it is a page fault. So they are telling that there is no page fault. So whatever the CPU is accessing, all the pages are there in the main memory. Is it clear? If a page fault occurs, then we have to go for the page fault service time. Meaning is that the operating system will take the control. If the particular page the CPU is accessing, if it is not available in the main memory, then operating system will take control, and then it will load the particular page from the secondary memory to the main memory. Is it clear? So how much time it will take, that we will call it as page fault service time. Is it clear? So there is no page faults. So if there is no page faults, then effective access time is 65 nanoseconds. I hope it is clear for you. If you still have any doubts related to this question, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.